Okay, guys, so this is lesson 3.5. So we're going to go through some of these quickly. A lot of this, guys, is review. So this is stuff you saw back in like the very first folder. So you can actually go back and review this particular one, these first few, just by going back to folder one. Now, again, we're emphasizing function notation, so we want to make sure that we always use the correct notation as we write this out. So now this first one, I'm going to just be solving this, okay, by plugging in the input or in this case, the output and looking for the opposite value. So here, if I'm looking for the input, I'm basically just taking this function. And again, pay attention to the letter. If it says F, then use the function F. If it says G, use the function G. Okay, and I'm going to plug in -2. So I want to make sure that I use parentheses as I work through this. So put parentheses in there. That way I know I need to multiply that. Okay, as I work through that and figure out the answer, you're going to have to do that part. I want to make sure that I answer it by putting f of -2 equals whatever that number is. This is your input, that's the output. And then you will do the same thing here. Okay, I'll start off just by writing this. Then I have a negative here, and I'm going to put the -2 inside parentheses where the x was. And don't forget that that's a -1. So I'm going to have to do exponents first. And then after I do the exponents, then I want to multiply the -1. Again, making sure that I put g of -2 as my answer. Now here, when you set these up, it wants you to find x if f of x equals 0. So instead of plugging the 0 into the x, now I plug in that number to where the f of x is. So basically, I'm going to set it up like this. 0 equals 3x minus 9. Okay, and then I just solve that. Okay, now here it's asking you to plug in a variable for the input. So literally all I'm doing is taking that variable and plugging it in to where the x variable is. And then that's it, because you can't solve that. There's no number to work out or operation to do, so that's pretty much it. So that is actually the answer for that one. Okay, so now this one, sketch and completely describe the vertex and the shape of this graph. Okay, so I'm going to just give you an example. Let's just say I've got x, let's say -3 cubed, and then -2. All right, so remember, that's your locator point, or kind of the middle of the graph. And this is a graph that's going to look like this. Okay, so the locator point's at 3 and -2. So I'm going to put that point down. And remember, you got to do this with your graph, so use that point, use that one for yours. Okay, then I'm going to go down 2, and then there's my locator point. So remember, this is a quick sketch, so I'm just going to kind of go up through that point and then kind of level out and go up again. Okay, arrows going both ways. Okay, the vertex would be that point. The shape, in this case, there's really no shape to describe here. In this case, you would describe the shape if it was like a parabola or a V or something. Okay, but we will say that it's cubic. All right. Okay, so now in this one, again, you're just going to set, this is just like before, except now we've got a fraction to multiply. Okay, so I'm going to set that up, and then I need to multiply this out. Now, just remember that in this case, let me give you guys another example, that when you square a fraction, so let's just say I'm going to use the function 2x squared plus 3, okay, instead of that one. So let's say, and my input, I'm going to make it, let's say g of, I don't know, 1/4. Okay, so that's the one I'm going to use, and that's the function I'm going to use. So now I plug that in. I have 2 times 1/4 squared plus 3. Okay, so I got to do this kind of one thing at a time. Now, you guys aren't going to have to multiply the 2, but I'm just going to add that in there just to show you. Okay, so when I square a fraction, I square the number on the top. So this basically becomes 1 squared over the number on the bottom squared. Okay, so now 1 squared is just 1. 4 squared is 16. Okay, so that's how you square a fraction. You square the top and then you square the bottom. Now I multiply these together. So 2 times, remember you multiply the whole number times the number on the top, so that would be 2/16. Okay, now I want to try to, in this case, I'll just simplify that. When you guys do this one, you won't have to simplify it. So I'm going to make this, divide these both by 2, so I get 1 over 8. So you will have to do this, however. You're going to have to add a fraction and a whole number. And remember, to do that, I'm going to have to put this number over 1 and then get them to be the same denominator. I need common denominators. So I multiply both the top and the bottom by this denominator to get it to be the same. So then it will be 1 over 8 plus 24 over 8, which is 25 over 8. Okay? And then, of course, I would write that out, I know I'm running out of room here, as g of 1 over 4 equals 25 over 8. So I think the key part here, guys, is that, one, when you square a fraction, square the top and the bottom, and then at the end here, when you have a fraction plus a whole number, I'm going to have to change denominators. Okay, now when you have a problem like this, it's basically just asking you to plug in the h plus 1 into your function. Okay, so if I was to have, let's say, g of, I don't know, h minus 1, okay, I would plug that in. Okay, and actually, let me leave myself some more room because I'm running out of room here. I'm going to use h minus 1. You guys have to use h plus 1. I plug in h minus 1 into the x, and now I just have to simplify all this. Now, if I put h minus 1 in there, I have to expand that. And you guys should have more room over here because you won't have to do as much work as I did since I added that 2 in there. Okay, so I expand that out. And now what I got to do is multiply this h minus 1. Okay, so h minus 1, I would basically take out the box and multiply that out. And after I do all that, I end up with h squared minus 2h plus 1, and then plus 3. And then what I would do now, let's just say you guys don't have the 2, right? So you can just take the parentheses down and just add up the like terms. Here at f, for me, I have to distribute the 2. So I distribute the 2, multiply it to here, here, and here. And now I add the 3. So eventually I end up with 2h squared minus 4h, and then add these like terms here, plus 5. Okay, and all of this is equal to, I'm running out of room, guys, I'm sorry. But I would write g of h minus 1 equals this. Okay. All right, so now in this one, you are using the graph to find these values. So for example, that's your x value. So I go into the graph and I go to the x value of 3, and then I look where the graph lines up, it's 1. Okay, so you're going to have to do this one with the 6. You're going to do that on your own. And then here, remember that these are the y values. So instead of starting on the x-axis, now I'm going to start on the y, figure out where it lines up, okay, and then determine what is that x value at that point. Same thing for the 6. I go up to 6. What is the y value what is the x value at that point? We've got to go over to the graph to find out. Okay, and you guys fill that in. Okay. So then down here, okay, this is a hyperbola. Okay. This is going to be a hyperbola shape, and I know that because I see the 1 over x kind of parent function there. Okay, anytime you have 1 over an x, you know that you're going to get something like this. Okay, you'll get some kind of shape that looks like that. Okay, and this is going to involve asymptotes. Okay, so the shape, seeing that it's 1 over x, I know it's a hyperbola. And again, that's that shape right there. Okay, the vertex, well, I look at the number inside the parentheses next to the x. It's the same thing. -5, okay, since that's plus 5, and the number on the outside to the right tells me the y value or the k value. Okay, now the other thing I want to know is the asymptotes. Okay, well, the asymptotes, okay, are going to come from the number on the bottom. And actually what I'm going to do is I'm going to give you guys a different example. Okay, so you kind of know how to work this out on your own. Okay, so let's say I've got 3 times 1 over x minus 2, and then plus 2. Actually, let's do plus a different number so you guys kind of know the difference. So let's do plus 4. Okay, so in that case, now my vertex would be, let's say, you guys already know what it is for you since I showed it to you. So it'd be 2 and 4 since mine's -2. Okay, my asymptotes would come from first the number inside. So it'd be x equals opposite of that. And then y equals whatever that is. So that doesn't change. So that's an asymptote. Now remember, with the asymptotes, you're going to graph as dashed lines. So this is x equals 2. That's this one. Okay, then y equals 4. So I go, remember, that's a horizontal line. So I go up 4 and then make a horizontal line at y equals 4. Okay, so the hyperbola is going to be determined off of this. Okay, then I'm also going to have a vertical stretch. Okay, because it's asking me to describe, so I'm giving all these descriptors. And then that number right there in the front, that one right in front tells me I have a vertical stretch of 3. So that would be your stretch right there. Okay, now what I'm going to do now is, since I have all these points, okay, I've got the kind of that vertex point in the middle. Okay, now what I can do is graph it. Okay, so basically I just run a line really close to this edge here and kind of start to curve it down and then make it go in this direction. Okay, and then I go to the opposite side to the top right and then do the same thing. Make it really close, and then it starts to curve and then work its way towards the other line, and then I make an arrow going the other direction. So make sure you guys are using this one to graph your own. Okay, so now using Desmos, okay, you're gonna graph both of these on your graph. So what I'm going to do is I'm going to use, for f of x, I'm going to use x cubed, let's say, I don't know, -2. Okay. And then I'll use g of x equals x minus 2 squared. Okay. Okay. And then it's going to ask me to solve for all these different values. Okay. So what I want to do is go to Desmos. I'm going to graph all my graphs. So first we're going to do the f of x equals x cubed. Okay, and then what was that, -2? Then down here, g of x. I don't know if it's going to let me do g of x. We'll see. X minus 2 cubed. Sorry, not cubed, squared. All right. So now the question is solve f of x equals 9, solve g of x equals 0, f of x equals -7. So basically on your graph, you need to pay attention to the letter. If it says solve f of x, I need to only pay attention to the f of x. So like here, for instance, what I could do is just turn this off if I want to get out of my way. So it says f of x equals 9. Okay, so then remember, that's numbers on the outside. So that means that's the y value. So what I'm going to do is I'm going to just move the graph up a little bit so I can see the 9. There it is. I go up to the 9 and I go over, and then I'm going to do my best to kind of land there on the 9 to get the y value of 9. Let's see there we go. And it's 2.22. All right, so that's what I'll write down. Okay, then we'll go over here, and now it says g of x equals 0. Well, I'm going to use just g of x now. Okay, and g of x at 0 will be right here. So if y is 0, what is the x? Well, that means I got to go all the way over to here, and boom, there it is. It's actually the vertex point. Okay, so that'd be 2, 0. So that means that the x value is actually 2. Okay, so now what is basically x if f of x equals -7 for which one? F. So now make sure I want to pay attention to the f graph and go down to -7. Here's -7. Remember, this is a y value. Then go over to the graph. And I'm going to try to drag it until I get to -7 for the y, and I get -1.7. 1.71. Okay, then it asked me to solve g of x equals 12. Now, if you're going to, on this one, we're actually doing it algebraically. This one, you guys are just using the graph. On this one, we're actually going to do it algebraically, okay? Okay, so what I'm going to do is I'm going to do, let's go g of x equals, what's the number I'm going to mess with? Let's do 24, okay? So what I'm going to do is I'm going to set my equation, g of x, equal to, let's write it out. So remember, I'm using this one. I'm using x minus 2. So x minus 2 squared equals 24. Okay, so that's what I'm going to do. Now, on this side, I've got x minus 2 squared and one number over here. So this I recognize as using the square roots method to solve a quadratic. Okay, so here, this just basically cancels out and becomes x minus 2. And then here, this becomes plus n minus the square root of 24. And I can't just square root 24. So what I'm going to have to do is I'm going to do the birthday cake. So I'm going to go over here and factor this out. And remember, you guys can use the tree method as well. Divide by the smallest prime number, divide by 2, divide by 2, divide by 2, and I get 3, so I divide by 3, and I get a 1. Okay, so now I'm going to circle groups of 2. I have 2 2s there, so that means I take 1 2 outside, and then the rest, I just have a 2 and a 3, so I multiply those, and I get 6. And remember, don't forget that this is plus and minus when you square root. Okay, so now I'm going to add the 2 to both sides. And then my answer ends up being 2 plus and minus 2 times the square root of 6. Okay, now if I was to ask for the decimal solution to that, then I would ask you guys to basically first do 2 plus 2 square root of 6, and then 2 minus 2 square root of 6. Okay, so I could do 2 plus 2 times the square root of 6. Okay, which would equal 6.9. And then here, I go back up and I do the same thing. You could do this on Desmos as well. -2.9. Okay, so those would be my different solutions right there. All right. Okay, so then for how many values of x does f of x equal g of x? So basically, when do the two graphs basically line up with one another, or when do they cross? If I look here, it looks like they only cross at this one point. Okay, so at this one point, which I can click on it and tells me 1.3 to 0.4. Okay, so in my case, it lines up once. For how many values? One time. Okay, are each of the functions even, odd, or neither? Okay, so what this means is that if I'm looking at the graph, let's say I take an x value to the right. If I take a positive x value to the right of this function, let's say 3, and I go up here and it says that that number is 1. Okay, if I go over to the negative of that same number, so in other words, if I go to positive 3 and then go over to -3, if -3 gives me the same y value, that's called an even function. Okay, but if you notice, if I go from 3 over to -3, I have to go pretty far up until I get up to here, which is 25. So that's definitely not the same. That's definitely not even. Okay, now an odd function means that if I start at the positive value of 3 and it gives me +1, if I go over to -3, it would give me -1. So let me show you a case where this does work. Okay, so let's just say I have x squared, just plain old x squared. If I go over to 2, the y value of 2 is 4. Okay, now if I go over to -2, the y value of -2 is also 4. So that's the exact same thing. That's an even function because if I go to the positive value of x, it gives me 4. If I go to the negative value of x, it also gives me 4. So that's even. The case of odd function would be something like this. Whereas if I go to, let's say, 2 and go up to the function, it gives me positive 8. But if I go to -2, it gives me the opposite of that, negative 8. So that's an odd function. But again, if I start moving it around, and let's say I drop it, let's say I go from this to -3 for this one, and move it to the right. Now when I go to, like, let's say 4, I go up here, it's 1. And if I go over to the -4, that's not even, it's not -1. Okay, so that's not odd. It's neither odd or even. Okay, so let's look at this example. So here I've got my x cubed minus 2. If I go to, let's say, 1, okay, the output for 1 is -1. Okay, then I go over here to -1. The output for -1 is -3. So the output here, positive 1 was 1. The output here at -1 is 3. Those aren't, it's neither odd nor even because those aren't like opposites and they're not the same. Okay, now let's look at g of x. G of x, let's say I go over to, I've already pointed this out. If I go to positive 3, that gives me 1. If I go to -3, that gives me a way bigger number, like 25. So that's not even close. It's not an opposite number or the same number. So these are going to be both neither. So really the only time that you're going to get even an odd function is when, like, your function is literally like right in the middle of your graph. So like here at x cubed and at x squared, notice how x squared at 1, it's positive 1. At -1, it's positive 1. So that's even. And then here, if I go to x cubed, at 1, it's positive 1. And at -1, it's -1. So it's like the opposite. That's an odd function. Okay, so really the only time you're going to get these even and odds is like when it's like right in the middle on the y-axis. That's typically when you'll see them. Okay. All right, so now here, graph and completely describe this function. So that says x2 to the x minus 1. 2 to the x minus 1. Okay, so let's just say I want to use Desmos. I want to use Desmos to find the x-intercept. So go ahead and use Desmos to find that. And I can use Desmos to find the y-intercept, sorry, the x-intercept and the y-intercept. And then I want to find the asymptote, which on the graph, you're going to see it. You're going to see your graph look kind of like this. It's going to be the line that this kind of comes down to and gets really close. It gets really close to some number right here, but doesn't actually touch it. So what is that number? That's going to be your asymptote. And it's going to be y. Since it's a horizontal asymptote, you're going to put y equals for that value. Okay, so figure out what that asymptote is. And then the last part I want you to describe is the domain and the range. Okay, so then go ahead and once you get that, kind of sketch it out. Put a quick sketch, put the asymptote wherever the asymptote is, graph your y-intercept, graph your x-intercept, and then kind of do a quick sketch. Okay. All right, now in this last one, you're going to graph this function. Again, you can use Desmos and completely describe it and then calculate these values. Okay, so again, this is squared function, so we're expecting a parabola. Okay, and I want the x-intercept, the y-intercept, and again, use Desmos. Also for this one, I'll write that in here, use Desmos for these last two. Okay, find the vertex, which you guys should be able to just look at that function. And to give you a tip on that one, there's no number to the right. So if there's no number to the right, that means it's 0. Okay, so use that to help find your vertex. Okay, so those are pretty much the important points for this one, and then write the domain and range. Okay, and then do a quick sketch of it. Okay, then you're going to be using these values to plug them in and calculate them. So here, -5, I'll kind of set this up for you guys. This is the input, so that will go inside the parentheses, and then you need to find the output. And when you get your answer, put g of -5 equals, okay, whatever that is. Okay, and this one, this is like that first page. I'm just going to plug in a plus 1 where there's an x. So what I got to do is plug in a plus 1 for the x, and then I still have plus 3 in there. And now what your job is, now you need to simplify this as much as you can. Okay, so I'm going to give you kind of the first step here. I'll get plus 4 here squared, and then guess what? You are going to have to expand this. So that's a plus 4 times a plus 4. You're going to have to use the box to multiply all that out and then distribute that too. Kind of like the problem I showed you guys on the first page. Very similar. Okay, so now on this one, on these two, notice how the number is now outside the parentheses. It says g of x equals that number, right? G of x equals. So now I put that in place of g of x. So 32 equals 2 times x plus 3 squared. Actually, let me flip this around just so it's more familiar to y'all. I'm going to put the 32 on the other side instead, which is fine. Doesn't matter which side you put it on. Okay, now I want to solve this. You're going to solve this very similar to how I solved this problem. Okay, except notice I don't have a number in front, so that means I need to get rid of this 2. So I'll give you that kind of first step. Divide by 2, I get x plus 3 squared equals 16. And then you're going to use the same method that I used up here to solve the rest. Okay, then we'll do the same over here. Oops, sorry, that should be a 3. Make it equal 0, and I can divide by 2 again. Okay, and I get x plus 3 equals 0. Same steps as before as you're going to use for this one. Just again, follow that example up there. All right.